Hi, welcome to Magnetite Math. Today on my channel, I'm going to be talking about triangular numbers, illustrated by this yellow thing of 6 spheres, 6 being a triangular number itself. First off, start with the definition of triangular numbers, and that is, say we take the natural numbers 1, 2, 3, 4, 5, so on. If we sum them up, each one, these are the triangular numbers. And so named because form a triangle of them. 1, 3, 6, etc. The triangular numbers have the interesting property that if you add up any two consecutive triangular numbers, you get a square number. So named because you can form a square out of them. In this case, like there's 9, or like in 16's case, there's 16 dots. So yeah, any two consecutive triangular numbers equals a square. Etc. So this is triangular numbers, illustrated by this here. And what you get if you sum up the triangular numbers. Well, then you got 1, 4, 10, 20, and 35. And it goes on and on. Well, these are the tetrahedral numbers. So named because you can stack triangles on top to form a tetrahedron, which you can think of as a pyramid with a triangular base. And it's interesting which way I flip it. It's basically the same. Each side change may be due to difference in sizes, individual different sizes in the marbles that I could do together. Then there's also the other kind of thing, and all these, by the way, are called figurate numbers. Let me see if I can spell that right. Anyhow, if you sum up the squares, say 1, 4, 9, these are all squares. And then let's say we sum those up. And then, alright, these are square numbers. And this would be pyramidal numbers, or square-based pyramidal numbers. For now, I'll just call it pyramidal. imagine what it looks like, but I'm going to show you anyway. This would be pyramidal number. And here's the other interesting thing is if you add any two of these together, you get what are called octahedral numbers. And this is octahedral. And either which way I rotate, it's the same. Except we're different coloring of those marbles. And that's called octahedral because there are 8 faces. 4 on top here, 4 faces on the bottom. See, 4 here, 4 here. This is tetrahedral because there are 4 sides. In addition to those figurate numbers, there's also what are known as hexagonal numbers. 1, 7, 19, 37, etc. And let's see. Those are more formally known as centered hexagonal numbers. And then there's also the star numbers. One does not directly create, it is created by 13, 37. So you notice 37 is both hexagonal and a star number. And these are related to actually to the triangular numbers. Let's see here, yeah. So to get a hexagonal number is 6 times a triangular number. I'm representing it by delta plus 1. And that would equal a hex. I'm calling it hex. A star number is equal to 12 times that plus 1 equals, I'll just call it star for start. This here, this one almost fall off on me. This is hexagonal number. This one is a number 19. The center is 1. Then the outer ring, that's 6 plus 1, that's 7. Then the outermost, all numbers all summed together is 19. So that's the third hexagonal number. And here is 37, which is a star number. And you see the center 19. See, 37 is a star number, but you can also see that it is also a hexagonal number. And it has this property where you take each of these balls, move them over one, and then you would see it would cover the original hexagon and make a bigger hexagon. So there are multiple numbers or different things, such as 36 is both a square and a triangular number. 37 is a star number. Let's see how well my drawing does. Not that great. And also a hexagonal number. Let's see how that works. Not too great. I'll just write it. There's one of my favorites, was 91. 91, let's see here, is a triangular. It's a hex number as well as a tetra. Our 21 is both a square and a star. Then there's an interesting number that's one of a kind, and that's 4,900. Also known as the cannonball number, because it's the only, let's see, yeah, it's the only number that can be written as both a square and as a square pyramid. And the analogy is to stacking cannonballs, so hence the cannonball.